The next lab you will be completing in this class is the analysis of an unknown salt, Part 3. In Parts 1 and 2 of this lab, you gathered results for the melting point, flame color, hygroscopy, and percent water of your unknown salt. During Part 3, you will be determining the density of your unknown salt using a pycnometer to allow you to better determine the identity of your unknown salt. During this lab, we will be using two flammable substances, cyclohexane and acetone. Because flammable substances tend to catch fire near open flames, no Bunsen burners will be used at all in this lab. Acetone, as many of you probably know, is an ingredient in nail polish remover and will remove any nail polish that you wear to lab. After lab, as always, make sure you wash your hands thoroughly to get rid of any flammable substances on your hands. In this lab, we're using a pycnometer. A pycnometer, or a pycnometer flask, has two parts. The flask, which is the bottom, and the stopper. The stopper has a hole that goes all the way through. Before you begin your experiment, you should make sure that your pycnometer is clean and dry. The best way to find this out is to hold it up to the light and look for any particles or any water droplets. If your pycnometer is dirty and you need to clean it, you should start by putting on your safety goggles and adding a small amount of acetone, less than 1 milliliter, to the flask. You can then gently move the acetone around to gather any substances that are left in your pycnometer. In the fume hood, there is a waste container for acetone. You'll start by taking off the lid, putting on the funnel, and emptying any acetone into the waste container. Once you've removed all the acetone from your pycnometer, you can use one of these squeezed bottles of air to dry the inside. If your pycnometer is not clean and dry after your first attempt with acetone, you can repeat the procedures one more time to clean and dry your pycnometer. Before you leave the hood, you should take the funnel out of the waste container and put the cap back on. In this lab, each student will receive their own pycnometer that holds approximately 25 milliliters of liquid. During the first part of this experiment, you'll be completing 3 trials to determine the precise volume of your individual pycnometer using deionized water. You should start by weighing the dry pycnometer, the flask, and the stopper, and using this mass for all 3 trials. Then add deionized water to the pycnometer and carefully place the cap on so that the cap fills with deionized water all the way to the top. Make sure the outside of the pycnometer is dry and weigh the filled pycnometer one more time. To measure the temperature of the water inside the pycnometer, pour the water into a test tube or a graduated cylinder and use a thermometer to measure the temperature of the water. Once you determine the temperature of the water, you can look up the density on one of the tables in the laboratory room. Never measure the temperature of water or any substance in a pycnometer by putting the thermometer in the pycnometer. This can cause both the thermometer and the pycnometer to break. Always pour the substance into a test tube before you measure the temperature. After you've determined the volume of your pycnometer using 3 trials, you're ready to begin the experiment to determine the density of your unknown salt. You use the volume you determined during the first part of the experiment to be the known volume of your pycnometer flask. Make sure your pycnometer is clean and dry before you begin the density experiment. Weigh the dry pycnometer, both the flask and the stopper, and add a small amount of unknown salt to the pycnometer. Weigh the pycnometer and the salt inside of it. After you take your pycnometer back to your lab bench, you can use cyclohexane to fill up the rest of the pycnometer. Just like with the water, you want to make sure that you fill the stopper with cyclohexane all the way to the top. Dry the outside and measure the mass of the pycnometer, cyclohexane, and salt. All of our unknown salts do not dissolve in cyclohexane, which makes cyclohexane a great solvent for determining the density. After you've measured the mass of your pycnometer, salt, and cyclohexane, take your pycnometer flask over to the fume hood. Pour the cyclohexane and salt into the waste container. Clean and rinse your pycnometer with deionized water. and then make sure it is dry using the acetone wash that I showed you at the beginning. After you have completed 3 trials of determining the density of your unknown salt, you'll be finished with this lab. I'm now going to show you what tables you should use for today's lab and how to calculate all of the measurements. So my first table looks like this for finding the volume of the pycnometer. Notice that it has a table number, table 1, and a table title, finding the volume of the pycnometer. There is then a column for description of what measurements I'll be taking, and a column for the measurements themselves. I'll start by measuring the mass of a dry flask. The mass of my pycnometer is 25.234 grams. Since I'm determining the volume of the pycnometer, I'm using deionized water and not cyclohexane. I'll fill the flask to the top of the stopper with water and measure the mass one more time. The mass of the flask and water is 44.618 grams. I then need to determine the mass of just the water inside the pycnometer, and to do that I can take the mass of the flask in water and subtract the mass of the dry flask. The mass of the water inside my pycnometer is 19.384 grams. I'll then take the water inside the pycnometer, pour it into a test tube or a graduated cylinder, and measure the temperature using a thermometer. My thermometer measures to the 10th place, 24.0 degrees Celsius. In the lab room, there will be a data table that you can use to determine the density of water at the temperature you measure it to be. The density of water at 24.0 degrees Celsius is 0.997296 grams per milliliter. Density is equal to mass divided by volume, so to determine the volume of the water inside the flask and the volume of the flask itself, take the mass of the water and divide it by density. The volume of my pycnometer is 19.437 milliliters. I'll then do 3 trials of this experiment to find the volume of the pycnometer flask. I'll average all 3 volumes together to get a final volume that I'll use for the next experiment. Because I'm just adding water to the pycnometer, there's no reason to dry it after every trial of this experiment. The second part of this experiment is to determine the density of the unknown salt. Notice that this table also has a table number and a table title, a column for description, and a column for the measurement. The volume of the flask I found in the first part of the experiment, 19.437 milliliters. After I have cleaned and dried the flask, I will measure its mass using a balance. The mass is 25.230 grams. I'll then add a small amount of salt to the flask and measure the mass once again. The measurement of the mass of my flask and salt is 27.120 grams. To find the mass of just the salt, I can take the mass of the flask and the salt and subtract the mass of just the flask. I added 1.890 grams of salt to my pycnometer. To the pycnometer containing salt, I will add cyclohexane all the way to the top of the stopper and measure the mass after drying the outside. The mass of the flask, salt, and cyclohexane is 39.165 grams. To find the mass of just the cyclohexane inside the flask, I'll take the mass of all things, mass, salt, and cyclohexane, and subtract the mass of just the flask and the salt. The mass of cyclohexane that I added to my pycnometer was 12.045 grams of cyclohexane. The density of cyclohexane can be found in the CRC in the laboratory room. You'll need to look that up when you come to lab. Once you have the density of cyclohexane and the mass of cyclohexane, you can determine the volume of the cyclohexane by taking the mass divided by the density. The volume of cyclohexane in my pycnometer flask is 15.56 milliliters. To find the volume of the salt that was added, I'm going to take the volume of the flask and subtract the volume of the cyclohexane. I added 3.877 milliliters of salt to my pycnometer flask. Once I have the 2 measurements, both mass and volume, I can determine density of my unknown salt. The mass of the salt up here is 1.890 grams, and the volume of the salt is 3.877 milliliters. If I take mass divided by volume, I can determine that the density of my unknown salt is 0.4874 grams per milliliter. 3 trials should be done with this experiment to determine the density of your unknown salt. You can then average the densities that you have confidence in to find a final density for your unknown salt. After every trial of this part of the experiment, you should rinse your pycnometer with deionized water and dry using acetone to make sure you have a clean and dry flask for the beginning of each trial. Like for all of our laboratory experiments, after you have finished the lab, make sure you dispose of all waste in the containers in the fume hood. Read them carefully. There are 3 waste containers in today's lab. You should then return any borrowed equipment, clean all of your glassware, put it back in your drawer, wipe off your lab bench, wash your hands, and you're free to leave lab.